universe is eventually going to die. The last star will collapse, the last black hole will decay into nothing, and the last thing will cease to exist. The universe is ultimately finite. But what exactly is meant by finite? A billion years? A trillion years? Past estimates put it between 10 to the 1100 years and 10 to the 32,000 years, a number unfathomably, almost intimidatingly large. There's only roughly 10 to the 80th atoms in the known universe for reference. This massive number is estimated by calculating with some of the slowest decaying objects in the universe, white dwarfs, and its theorized successor, black dwarfs, which in theory is a dead white dwarf, would explode. Though this number did not take numerous different factors into consideration, namely Hawking radiation, which would change this number dramatically. A relatively new study took these factors into consideration, putting the number at roughly 10 to the 79th, a number mathematically invisible to the former estimate. It's still an incredibly long time, but way sooner than expected. And in that amount of time, even the biggest black holes will be gone. Anything else that isn't a sad remnant of a once bright universe way before that, whether it's from Hawking radiation, being ripped apart, or another factor, everything will be gone. Space is kind of horrifying, tragic almost. Even beyond its eventual demise, the universe is filled with grim reminders of the horrific reality it is, which includes its death, but is certainly not limited to it. What bothers me the most is the fact that Earth is pretty much it. Nowhere else in the universe as of 2025 can contain life, let alone humans. And as a general trend, all of the universe isn't even temporarily livable outside of technology. If you ended up in space without a suit, a helmet, or oxygen, your blood would quickly become deoxygenated due to space being a vacuum. Your lungs would collapse in about 30 seconds. Your respiratory system would fail even sooner. And in roughly a minute and a half, you would be dead from asphyxiation. Even with oxygen, your lifespan would only be extended by a few minutes. The low pressure would cause your bodily fluids to bubble and boil. For reference, this condition, called eublism, occurs at high altitudes on Earth and can be lethal. So as you can imagine, it's much worse in space. Your body would blow to twice its normal size, causing it to surprisingly not burst, which is a common misconception. Human skin and tissues are very flexible and can handle such extremes. So while this would eventually be deadly, it won't get you in the short term. Ignoring pressure and oxygen for a moment, you'll either be cooked to a cancerous crisp or slowly freeze to death. Outside of Earth, there's no atmosphere to protect you. You would receive severe sunburns in minutes, and the radiation given off by the sun or any star you're near would eventually kill you in what could be months or longer. In the event of a solar flare, however, you would receive a lethal dose of radiation in mere hours. Assuming you're far away from any stars or celestial objects, though it might take a while, your body would slowly cool down. Despite space being extremely cold, there's no medium for heat to leave your body, so you would cool down through thermal radiation, caused by the significant difference between the temperature of space and your body temperature. While I don't know exactly how long this is, or how this exactly happens, I can't imagine this not being torture. Of course though, in a situation where you're stranded in deep space, the lack of food or water would probably get you first. And realistically, being stranded in space, especially without a suit, is unlikely to happen, even for astronauts. But this is where another issue occurs. I mentioned earlier that just about all of the universe isn't even temporarily livable outside of technology. But over the long term, even with technology, providing for needs, maintaining livable temperatures and pressure, protecting against harmful influences, and more, space is still detrimental to the human body. We are just not meant to live in a weightless environment. A study done in 2017 looked how space affected the brains of 34 astronauts, half only being in space for a short duration, or about 2 weeks, and the other for about half a year. They took an MRI before and after to look for any changes. The short duration group showed little changes in the brain structure or health, while the long duration group's results were rather concerning. Narrowing of the central sulcus, brain displacement, and a reduction of cerebrospinal fluid spaces at the top of the skull. The known potential side effects of these are vision problems, headaches, eye strain, and cognitive changes, with any long-term consequences unknown. The body isn't spared from the effects of space either. Muscles tend to atrophy, especially legs and other muscles used to stand, due to the fact that you don't have to use them nearly as much in space. Muscles can atrophy up to 20% in around a week. Bone mass follows this same trend, due to a similar reason, though it's much slower. about 1.5% a month, though despite being slower, this adds up over time. The ISS is equipped with treadmills to help mitigate these, but unfortunately microgravity still has its effects. The list of adverse side effects from space goes on, from physical to physiological to psychological. Research on how to mitigate and potentially even prevent these side effects from happening is still ongoing, a lot of which is geared towards long-term yet temporary visits to space for select people. Which brings me to an important point. If Earth goes, that's it. Humanity, as well as what could be life as we know it, is gone. The best alternatives that have been discovered can only be labeled as potentially habitable, many of them not being habitable at all. The only qualifying factors being that it's within the habitable or Goldilocks zone, and that it's a relatively similar mass to Earth, giving it the potential of being rocky. Though, more often than not, it's either not actually rocky or has another glaring issue with it. Many things have to line up for a planet to even have a chance of life, and there's only so much science can do currently to investigate these things. I mean, it's still going to be another 6 years until we can map Europa, the moon of Jupiter, so planets multiple light years away are off the charts. As of now, the future for us and exoplanets are uncertain. The closest exoplanet on the habitable list and what could be our best chance is Proxima Centauri b, located approximately 4.24 light years away. It's only a little bigger than Earth, giving it the potential to be rocky, and it orbits in the Goldilocks zone. In many ways, it's a great fit, yet there are many potential and known issues with it along with many other exoplanets. Those issues being we can only guess about its atmosphere, water content, and other important conditions, along with issues that come from the fact that the star it orbits, Proxima Centauri, is a red dwarf. Red dwarfs are small, slow-burning stars, so in the long run they're a good bet for life far in the future. All around, red dwarfs are pretty minuscule compared to stars like our sun. Aside from one small detail, that being its violent solar flares, often disproportionately massive, which are significant enough to strip away a planet's atmosphere, and generally make life impossible on its orbiting planets. Planets in the Goldilocks zone of a red dwarf tend to orbit very close to the actual star, significantly closer than we orbit our sun, making these flares only the deadlier. Along with this, planets orbiting these stars are almost always tidally locked, meaning that one side of the planet always faces their star. Without an atmosphere, half the planet is too hot for life and half the planet is too cold for life, with a potentially neutral terminator zone, the center line. Of course though, if the planet had an atmosphere, this specific issue wouldn't be a problem. Though, for reasons mentioned earlier, these are unlikely to exist, unless the planet has a strong magnetic field to protect itself from harmful space weather. But, rather ironically, planets which are tidally locked also tend to not have a magnetic field. It's not impossible, but it's much more unlikely, making Proxima Centauri more likely than not a no-go. Even if we look at a planet without these issues, namely Kepler 452b, a planet that orbits a yellow star and is even called a super-Earth by scientists and an Earth 2.0 by the public, assuming it's rocky, has an atmosphere, a magnetic field, contains the necessary gases to support life, doesn't have any harsh atmospheric conditions, and is generally just perfect, it would take 30 million years to travel there. This is unfortunately the reality of our future. Even Proxima Centauri, the closest star to us, would take thousands and thousands of years to travel to. Technology is getting better, but until we get wormhole spaceships or light-speed travel, we're confined to our solar system alone, and until we can terraform to Earth. Which is kind of concerning, because, as special as Earth and humanity are, they're incredibly fragile. On July 23rd of 2012, a solar event called a coronal mass ejection took place, which to put it basically is an expulsion of matter into space from the sun. If it would have hit Earth, technology, power grids, satellites would have been fried and destroyed at large. We would still be recovering from it today, and it missed Earth by a margin of 9 days. It really feels like we as a species and as a planet are on the constant verge of destruction. Solar events like coronal mass ejection and the closely related solar flares threatening technology as we know it, wandering comets and asteroids threatening cities and larger, and strange events threatening the entire world. Solar flares and asteroids are on the news much more often than any other cataclysmic space event, as they're much more common among such events. But these strange events that, while not as likely, are world-ending and often, even with forewarning, completely unavoidable. One of the scariest of these strange events being gamma ray bursts, which are powerful explosions of gamma rays, extremely energetic electromagnetic radiation, that occur in high-energy space events, most commonly star collapses and collisions. Gamma ray bursts are very brief, typically lasting anywhere between a few milliseconds and a few minutes or longer, depending on the source, though in this brief amount of time a dangerous amount of energy is released. On October 9th, 2022, a gamma ray burst, dubbed GRB 221009A, hit Earth, caused by the collapse of a massive star. It impacted Earth's atmosphere, disrupting satellite communications and triggering lightning detectors in India. It was so bright it blinded multiple satellites and gamma ray detecting instruments, and it was the strongest gamma ray burst in recorded history. Though with all this, all gamma ray bursts are supposed to be world-ending, not mildly inconvenient. Well, that would have likely been the case if it didn't happen 2.4 billion light years away. A gamma ray burst within a few thousand light years of Earth would cause significant issues, stripping away the ozone layer and causing a mass extinction. A possible explanation for the late Horrifiying mass extinction, which wiped out about 90% of sea life, was a gamma ray burst from around this distance, though the theory has no evidence. A gamma ray burst within a few hundred light years could potentially vaporize Earth, though, to be fair, a star that close and large hitting Earth is more than extremely unlikely. Gamma ray bursts tend to be very narrow, so the chance of one significant enough to cause a mass extinction event directly hitting us is unlikely, but it's still a possibility, and a very scary one at that. Another strange world-ending event, or more accurately, object, is a wandering black hole, which are three words that are terrifying to see together. Nomadic black holes are typically created when already wandering stars collapse into black holes, or a black hole is ejected from some form of orbit. The Milky Way is riddled with black holes, around 100 million, which is immensely disturbing. It's estimated the closest black hole to us is around 80 light years away, which in terms of the Milky Way is really close, and there might be one even closer than that to us. Black holes are notoriously hard to spot, as they are the embodiment of darkness and warp space and reality as we know it. We were only able to photograph M87 because of the star behind it. A black hole could be approaching our solar system, and we wouldn't know until we were ripped out of orbit or swallowed whole. Though, honestly, a nomadic black hole is even less likely to destroy Earth than a gamma ray burst. But, once again, it is a possibility, and it just takes one of these things to destroy everything. There's a lot of these things. Things like gamma ray bursts and supernova are happening constantly, though on a scale our minds can hardly understand. A supernova happens every 50 to 100 years in the Milky Way, a galaxy with hundreds of billions of stars. So how many do you think happened in that time in the observable universe? 50,000? 100,000? A million? Approximately 50 to 100 billion supernova occur in that same 50 to 100 year time. And that's just what we can see. We don't truly know how big the actual universe is, hence the name Observable Universe. Estimates put it at least 250 times the size of the observable universe, though once again, it's unknown. Only 13.8 billion light years of information has reached us, or more accurately, due to space expansion, 45.7 billion. Despite all we know, we don't know much. Most of the universe is still relatively mysterious. We can't even see or interact with most of it. 4.2 times 10 to the negative 22 of the universe is physical matter, which is an almost infinitesimally small number. The universe is pretty empty. Despite the Milky Way being 27,000 light years long, the closest galaxy to the Milky Way, Andromeda, is 2.5 million light years away. And if the Milky Way and Andromeda weren't heading towards each other, that 2.5 million would only grow due to mysterious forces pulling and tugging at galaxies in the universe itself. This mysterious force being dark energy, which serves as an explanation as to why the universe is expanding and galaxies are moving away from each other. Scientists generally agree on its existence, as no other explanation makes sense. Though weirdly enough, it's not the only factor moving galaxies. At least it's not a good explanation as to why our galaxy and its neighboring galaxies are all being drawn to a mysterious center. A center dubbed the Great Attractor, which is a coincidentally mysterious object. Coincidentally mysterious because it's right where we can't see it. Part of the universe is obscured to us because galactic dust, gas, and stars are in the way, called the zone of avoidance. Many galaxies and, unfortunately, the Great Attractor are in this area, so we can't be 100% sure of what it is. But seeing how galaxies tend to clump up to make superclusters, it's generally agreed upon that it's a relatively tightly packed concentration of galaxies, whose collective gravity is strong enough to pull the rest of the Laniakea supercluster towards it. The Laniakea supercluster, for those who don't know, is a massive conglomerate of about 100,000 galaxies, including our very own Milky Way. Laniakea is Hawaiian for measurable heaven, by the way. Cool fact I thought I'd share. Despite this, it's kind of unnerving that us and our entire galaxy are getting pulled towards something we can't even see. When things get big and significant enough, in my opinion, they start to be innately scary. Processing how big the Milky Way is just on its own is overwhelming. Or honestly, even the distance from us to local stars. Compared to us and what we as a species can do in terms of travel, just a light year alone is a lot. The universe being mostly empty and the cosmic scale being overwhelming leads me to talk about a type of cosmic object I find absolutely terrifying. That being dark nebula, and space voids in general like the Butez Void. This picture, by the way, is not the Butez Void. It is Bernard 68, a dark nebula. I initially thought it was and is often used as if it is, so I brought it up. Thank you, Raging Willies. Though it shares the same cosmological dread as the Void. That being they're both incomprehensibly large stretches of utter darkness. Bernard 68 being about half a light year big, filled with stardust so dense it blocks out light and the stars behind it. It's not technically a cosmic void, but still intimidating. The Butez Void is, however, and it's not dark because it blocks out light. It's dark because just about nothing is there. In a radius of about 330 million light years, there are only 60 galaxies. On average, there should be a few thousand there, but there isn't. And that space with that many galaxies would still be pretty empty. But 60, that's practically dead. Butez Void isn't the only one either. Both voids and dark nebulae almost make it look like a massive space infection is actively ravaging through space. And just imagining getting stuck in such a place is fuel for nightmares. Just being out there, stuck in eternal darkness for the rest of your life, which is determined by how long your resources are going to last, is pretty scary, and serves as a grim reminder of our fate, or more specifically, the fate of the universe, which I would like to get back to wrap up this video. I mentioned at the start of the video that the amount of years the universe is supposed to last has significantly diminished over years with the progression of science, which I find interesting, because who knows if there's a factor we haven't discovered yet out there in the universe that would diminish that number further. And along with this, we don't even really know how the universe will end. Of course, the gradual death of the universe, or more accurately, heat death, is arguably the most probable one. Though there are, for the sake of this video, two other possible ends which are much more violent than heat death. All of them, including heat death, are based on the expansion of the universe and the closely related dark energy. Heat death assumes the universe will perpetually expand at the same rate until all energy is evenly distributed and nothing else can form. This would mean the universe is coasting and dark energy doesn't change, or exponentially accelerate. But if it did accelerate, it would look something more like this. This is the Big Rip, and it's arguably the most violent ending possible. If the Big Rip hypothetically happened, the first apparent sign would appear about 22 billion years from now. Gravity would weaken, and galaxies would separate from each other. That would be 200 million years before it happened. 60 million years before it happens, gravity would become even weaker. Galaxies themselves would begin to fall apart and disintegrate. 3 months before, and even solar systems would follow. And in the last few minutes, everything would quickly be destroyed. Stars and planets would be reduced to mere atoms, and those atoms too would be quickly shredded, until the universe is infinitely big, and absolutely everything is gone. The Big Rip is a pretty disturbing possibility. I mean, the heat death of the universe isn't much better, but still, this would happen a lot sooner than heat death. Though with the mysterious nature of dark energy, other potential endings are also possible. Both heat death and the Big Rip assume dark energy would continue to expand the universe into infinity, which is most likely according to what we currently know. But there's no telling if it would continue to behave this way forever, so it's entirely possible the universe could just stop expanding. Dark energy could eventually slow down to a stop, and the universe could get stuck at the same size for the rest of time. Though assuming dark energy might not only expand the universe, brings another disturbing theory for the end. The Big Crunch, where instead of stopping when the cosmic dial reaches absolute zero, it starts to go the other way, contracting, reverting back to the same way it started. This would occur in a similar time frame to the Big Rip, somewhere between 10 and 100 billion years potentially. All matter would slowly but surely be pulled into each other. Everything would become hotter and hotter. Assuming life is still around, in a very short time frame life will suffer, until they all die out, whether it's because it got smacked by a celestial object or couldn't handle the heat. If somehow any life form had the tech to withstand such extreme temperatures, that tech wouldn't hold on for much longer, as the universe would slowly approach what is infinite temperature. Stars themselves would melt and combust. Once everything becomes one, that one thing will also be gone, like a reverse Big Bang. Just like the Big Rip, time and space will be gone, in a violent fashion at that. Other theories also coexist with this one and the ones mentioned before. Big Bounce states that once the universe collapses into nothing, it'll bounce back with another Big Bang, in a cyclical fashion. Theories also exist outside these aforementioned theories at the end, namely false vacuum, or vacuum decay theory, which to put it simply, states that if we live in a false vacuum and enter a true vacuum, the universe will be destroyed at large through a decay wave of sorts. And with that, that's kind of it. There doesn't seem to be any other potential endings of the universe outside of crazy people saying a black hole is going to consume everything. We're just left with cosmic uncertainty, which pretty much means we don't know much. The fate of the universe is ultimately unknown. All we know is it's coming, and there's nothing we can do about it. This video focused almost solely on the depressing and grim aspects of the universe, and nitpick these things. And while there are many, I'm here to tell you that's not that bad. You won't have to worry about almost any of this in your lifetime, and we have billions of years to figure out the rest of these issues. Space is scary, but it's just as beautiful. Have a good night.